Hello there, Primary 7 candidates, and welcome to today's Explainer. I am so incredibly excited to be your teacher today because we're going to master a seriously important topic for your upcoming mathematics exams: number patterns and finding the missing number. Think of today like a fun, interactive puzzle session. By the time we're done here, you're going to be a master detective. You'll be able to look at any sequence of numbers, spot those hidden clues, and figure out exactly what's missing. So, are you ready to crack the code? Let's do it.
Okay, let's dive right into our agenda. Today's lesson plan covers what are number patterns, types of numbers, finding the secret rule, solving missing numbers, and finally, your final challenge.
Section 1. What are number patterns? Now, in mathematics, numbers rarely just sit there randomly, right? They love to form orderly lines and follow strict rules. And as a P7 candidate, well, your job is to figure out that rule. So, what's the missing number in this sequence? We've got 2, 4, then a blank space, then 8, 10. I'm going to pause for just a second. Think about how we get from 2 to 4. Did you guess it? The missing number is 6. A massive congratulations if you got that right. You see, a pattern, or a sequence, is really just a list of numbers that follows a specific secret rule. And in this case, the secret rule was simply to add 2 each time. 2 plus 2 is 4, 4 plus 2 is 6. Easy, right? And your P7 mathematics syllabus tells us exactly why we learn this stuff. It says number patterns are all about prediction. Learning these patterns completely builds up your critical thinking and your problem-solving skills. When you sit down in that exam room, the examiners really want to see if you can predict what happens next. They want to see if you can look at the facts and solve the problem right in front of you. Section 2, types of numbers. Think of a builder making a house. They absolutely need bricks, right? Well, in math, our bricks are the different types of numbers. First, we have prime numbers. A prime number has only 2 factors, 1 and itself. The number 3 is a great example. Then, we have composite numbers. Now, these have more than 2 factors, like the number 4. Identifying if a sequence is made entirely of prime or composite numbers, that is a massive clue. Next up, can you remember what square and cubic numbers are? A square number is formed when you multiply a number by itself. So, 3 times 3 is 9, making 9 a square number. A cubic number is when you multiply a number by itself 3 times. So, 2 times 2 times 2 is 8. That makes 8 a cubic number. You've got to keep your eyes peeled for sequences like 1, 4, 9, 16, because those are squares hiding right in plain sight. Finally, let's wrap up the types of numbers from the syllabus. We've got triangular numbers, which can literally form a triangle dot pattern, like 1, 3, 6, and 10. We have odd numbers, which cannot be divided by 2 evenly, like 1, 3, 5, and 7. And of course, even numbers, which can be divided by 2, like 2, 4, 6, and 8. Definitely remember these definitions, okay? They're the absolute essential building blocks of every exam question you'll face on this topic. Section 3, finding the secret rule. Now that we actually know our building blocks, how do we go about finding the secret rule? The very first thing you must look for is direction. Ask yourself, is this an increasing progression, meaning the numbers are getting bigger? Or is it a decreasing progression, where the numbers are getting smaller? Increasing means we're dealing with addition or multiplication. Decreasing means it's got to be subtraction or division. So, let's say you think you've found the rule. Maybe you think the rule is multiply by 3. How do you actually test it? How can you sit in that exam room and be 100% sure your secret rule is correct before you go ahead and write down your final answer? Well, we can use the divisibility tests you've already learned in the P7 syllabus. Whether you're testing for 6, 8, 9, 10, or 11, these rules are huge time savers. For example, you know a number is divisible by 10 if it ends in 0, right? And it's divisible by 9 if the sum of its digits is a multiple of 9. Using these tests helps you check if your numbers fit the pattern perfectly, all without having to do long, complicated division. So, let's put all of this together into a simple, repeatable 3-step method that you can use every single time. Step 1, look at the numbers and identify what types of numbers they are. Are they odds, evens, primes? Step 2, is the sequence increasing or decreasing? And step 3, find the common difference by subtracting the smaller number from the bigger number right next to it, or just apply your number type rule. Section 4, solving missing numbers. All right, candidates, it's time to practice what we just learned. Let's put our detective hats back on. Here's a sequence straight from your syllabus concepts. We have 3,
6, a blank space, 12, and 15. I want you to apply those 3 steps. Are they increasing or decreasing? And what exactly is the difference between them?
Let's break this down together, logically. Step 1. The numbers are going up, from 3 to 15. So for sure, it's an increasing progression. That means we're adding or multiplying. Step 2. Let's check that difference. 6 minus 3 is 3. 15 minus 12 is also 3. So the secret rule has to be adding 3. Step 3. Let's apply the rule to our missing space. 6 plus 3 equals what? The answer is 9. Excellent work. You found the common difference, you identified the secret rule of adding 3, and you completely solved the puzzle. 3, 6, 9, 12, 15. It fits perfectly. You should be super proud of your critical thinking on this one.
Section 5, your final challenge.
We've reached the end of today's explainer, but before I let you go, it's time for a final test. This challenge is really going to require you to think critically about everything we've discussed today. Odd, even, prime, composite, square, cubic, and triangular numbers. Because sometimes the secret rule isn't about adding or subtracting, it's that the numbers themselves belong to a special family. As you look at this final puzzle, just remember my advice. Don't panic, just follow your steps. Look at the numbers. Ask if they're increasing or decreasing. Look really closely at the gaps between the numbers, and if those gaps don't seem to make sense, ask yourself, are these numbers part of a special family like squares or primes? So, here is your final puzzle. 2, 3, 5, 7, 11. What comes next? Look at those numbers very carefully. They're increasing, sure, but the gaps are different every single time. Could they be a special type of number we learned about today? Well, I'm going to let you figure that one out on your own. Keep practicing these patterns, always trust your steps, and you're going to do wonderfully in your exams. Until next time, keep learning and keep solving.